In the last video, we saw a passive attack on WEP using aircrack-ng. We will see another passive attack on WEP because the default uses the very efficient PTW that does not require a lot of different IVs. So in just over 20,000 IVs, it was able to find the WEP key. We can also use an older but less efficient way, which is the correct way, and we will see that in this video. Both are passive attacks, meaning that the attacker is just listening for frames in the Wi-Fi network. And this has the advantage that it's harder to be detected because it's just listening. So whoever's operating the Wi-Fi network would probably have no idea that the attacker is listening, capturing frames, and then running this attack on the frames. The disadvantage of using passive attacks is that it needs traffic to be in the Wi-Fi network. When we have less active network, it might take a long time to gather enough different IVs. Still not yet. 20,000, and so 20,029 IVs. At that point, it found the key. 41A19D05AA. The file is continuing to transfer, so we see that we have number of data frames still increasing. And what we're going to do is to try to use a correct attack, which is less efficient, so that needs more IVs. So we put a -K and let it run. So 150 something thousand IVs, still not enough. Still going. Speeding up the video here to save time. 181,000 IVs. Thankfully, the file that we're transferring is pretty large, so the number of data frames are still going up very, very quickly. By the way, we see what's happening here. There's two stations that are connected to this access point, associated with this access point, and I'm transferring a file from one of them. So I have turned on file sharing on one of them, and the file transfer is happening from that shared folder to the other one. So that's why we have the number of frames for both of these stations increasing rapidly, because a file is being transferred from one to the other, going to the access point, and then from the access point to the other station. And the total number of frames is effectively then double of the individual number of frames for the two of them. Over 300,000 IVs so far. It's a statistical attack, so sometimes we are less fortunate and we might need more IVs, other times fewer. Speeding up the video again. This time the speed up is much more. And finally the key is found here. It took 513,000 IVs, but finally it did it. So it's a statistical method, and sometimes it just takes that many IVs. I tried another time, it was like about 200,000. It varies, and it can vary quite a lot. We have seen a couple of passive attacks on WEP networks. We will be looking at some active attacks in the next video. Let's talk a bit about them before we get into that. In the case where a network is idle or there's low traffic, it helps to be able to inject frames to stimulate traffic to be coming from the access point or other devices in this network. This allows the attacker to be able to capture enough frames with different IVs in order to recover the WEP key. The disadvantage of active attacks is that there's a higher chance of detection. Note also that it's not normal traffic that will be injected in these attacks. So it's quite possible that an access point could detect anomalous, strange traffic and realize that an active attack is being carried out. The most common varieties of active attacks on WEP are listed here. So up, request, replay, chop, and fragmentation. We will be showing these in subsequent videos. And we will be using a tool known as Air Replay NG to do this. We have already seen Air Replay NG used for injection testing, and that's with the -9 or -- test option. There are also other options. For example, --- count to or -0. These are synonymous, just like -9 and - test were synonymous. This is to deauthenticate a station or all stations. This is useful in certain attacks because then you might expect that the stations will try to reauthenticate, and that traffic could be valuable for certain attacks. There's other things as well, but for now we want to focus on - up replay or -3, - chop or -4, and - fragment or -5.